welcome to calculus. Welcome to Wonky Dog. All right, she was barking, and I apologize in advance for any barking dogs in the background. They have been going crazy. So we did the related rates problem. Oh, you're going down and you're coming up. You come here. Oh, stop. Give it a rest. You done? Sorry. Okay. The related rates section, section 5.4, doesn't sound like it went well. So I'm going to go over all the homework. One of the questions I had that I'm going to try and clear up is, how do I know whether it's like dx over dt, dy over dt, or dy over dx? How do I know what that bottom number is? I know what that bottom number is either because they tell me, or if I'm doing a word problem and they ask about, they're talking about velocity and they're talking about how fast something went and they're talking about distances. Velocity, how fast something happens, is based on time. Therefore, when you do the derivative, you are doing the derivative with respect to time, because if they want to know what the velocity was and all you know is the displacement, you have to do the derivative of displacement to get the velocity. But again, velocity is dependent upon time, right? I'm going 50 meters in how long? That's how you figure out velocity. In just a general question, like y is equal to this, usually you are doing the derivative with respect to x. So in this first question, y is equal to x squared plus 4x, I would assume that I would be doing the derivative of y with respect to x, because x appears to be the unknown. Hi. Yes. Because x appears to be the unknown. But in the instructions, they tell me find dx, if dx over dt is 10 and x is 5, figure out what dy over dt is. So they're actually telling us we're doing the derivative with respect to time. They're actually telling us that, okay? So they're telling us what that bottom has to be. So when I do the derivative, hon, you want to call Wicket?
Yeah, is he upstairs?
Yes.
Okay.
And he's doing his spinny thing. Go. Go, go, go.
Come on. Let's go, buddy.
Okay. So when I do the derivative, I'm doing it with respect to t, with respect to time. How do I know that? Because in the instructions, they told me that. If they hadn't have, I would have assumed that I was doing the derivative with respect to x, and I would have been, because they didn't tell me any different. So in this one, when I do the derivative, sorry, I'm hot, and that's really unusual. If I do the derivative of y, because it's y to the first, so I bring my 1 down, decrease my exponent by 1, so the derivative of y is just 1. But I have to say I did the derivative of y with respect to time. Now I have to do the derivative of x squared. Well, that would be 2x. Now, again, if I was doing the derivative with respect to x, then I wouldn't put dx over dx, because dx over dx is just 1 anyway, so I wouldn't bother to put it. But I'm not doing that. I'm doing it with respect to t. So I actually have to say that I just did the derivative of x, but I did it with respect to t. I did it on the understanding that time is the unknown factor in here, because they told me it was, back there, plus 4x. So the derivative of 4x would be 4, but again, I took that derivative of x with respect to time. So now what I have is just dy over dt is equal to 2x times dx over dt, whoops, I don't know why I was going to put a bracket there, plus 4 times dx over dt. Now, back up here, they said they want us to figure out what dy over dt is if x is 5. So 2 times 5. And dx over dt is 10. So times 10 plus 4 times 10. So dy over dt is 2 times 5 is 10 times 10 is 100 plus 40. It is 140. And I will double check my answer because this is calculus and I am very skilled at screwing it up. Aren't you glad you have such a knowledgeable teacher who screws it up? 5.4, number 1 is 140. Yay. Okay. The next thing I asked you to do was I asked you to do 2a and b. 2a and b. So 2a says if you are given that volume is 4 over 3 pi r cubed, surface area of a sphere, by the way, or sorry, volume of a sphere, find dr over dt if, in A, if dv over dt is 5 and r is 8. So, again, they're telling us we're doing the derivative with respect to time here, okay? So, the derivative of v is 1, but I have to say I did the derivative of v with respect to time. They do not bother to get rid of the pi. They don't do 4 over 3 times pi in their calculator. They just leave pi there. Now, it's not a variable because it's not a letter. It's a number, but they just leave it as pi. You can do that in math. So really what I'm doing the derivative of is the r cubed. So I'm going to bring this down and I'm going to multiply it by 4 over 3. 3 times 4 over 3 is 4. So this is 4 pi r squared because I decreased my exponent by 1. I brought the 3 down in front, I decreased my exponent by 1. But I have to say, listen, I did the derivative of r with respect to time. So I've done the derivative. Now they want us to figure out dr over dt, but they tell us dv over dt is 5. And that's 4 pi times r, and they tell us r is 8 squared dr over dt. Now, again, they don't bother at the back of the book, because I glanced at it while I was back there, they don't bother to get rid of the pi. They don't bother to multiply it out. They just leave it as pi. You can do that. So I would do 8 squared is 64, and 64 times 4, Harriet. There she is. Hold on. She's buried. I am as disorganized at home as I am at work. All right, maybe more. 64 times 4 is 256. So I have 5 is equal to 256 pi dr over dt. Now remember, I'm trying to isolate that. So I'm just going to divide by 256 pi. So I'm going to divide this by 256 pi. So dr over dt is 5 over 256 pi. Ta-da! And you just leave it like that. Again, you could potentially do 256 times pi. The problem with that is pi is an irrational number which has no end. So technically when you multiply it by 256, that number is not going to have an end. So rather than have this big long decimal thing, they just leave it because that's cleaner. 256 pi. So 2b is going to be very, 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 very similar to b. They want us still to find dr dt. This time dv over dt is negative 20. And the diameter is 10, which means the radius is 5. Now I was stupid and I just erased this, but I didn't really need to do the derivative again. So the derivative of v is 1 dv over dt Bring that 3 down, that's going to be 4 pi r squared dr over dt. I didn't need to do the derivative all over again, but I erased it, so I had to do it again. Because I have this, it's just a matter of putting the numbers in. So dv over dt is negative 20, 4 pi times 5 squared dr over dt. So 5 squared is 25, times 4 is 100. So negative 20 is equal to 100 pi dr over dt. So I'm going to divide this by 100 pi. So I'm going to divide this by 100 pi. So 20 over 100, that would reduce to negative 1 over 5 pi equals dr over dt. And that would be my answer. Again, I would just leave it in terms of pi, wouldn't do anything else with it. Hopefully you're going, oh, I hope. This is what I don't like about the whole online thing is I can't see whether or not you're going, oh, I don't know. So I'm just going to assume I am a wonderful, wonderful teacher and I am making everything crystal clear for you. That's what I'm going to assume. Let me live in my little world. All right, number 6 says, oh, this is one of those rates of change thing. A piece of lumber at a construction site is resting against the frame of a house. So here's the house, here's the ground, here's a piece of lumber leaning up against it. You could have done it the other way. That's just how it came out for me. The lumber is 4 meters long. That's the lumber, so it's 4 meters long. If the bottom of the lumber slides away from the wall at a rate of 0.25 meters per second, so it's sliding away from this wall at 0.25 meters per second. Now that's a rate. So that means that's, like, this is a Z, right? And this would be X and this would be Y. But 0.25 meters per second is not your X because the X, Y, and Z are lengths. This is a rate. So this is actually dx over dt. And again, I know it's time because it's per second, right? The X is a distance, meters. The bottom of velocity is a time. It's seconds. So that's how I know I'm doing the derivative with respect to time. All right. How fast is the top of the lumber falling down? So how fast is it going down? So at what rate is it sliding down this wall? So I'm actually looking for dy over dt. That's what I'm looking for. When the bottom of the lumber is 2 meters away from the wall. So this is 2 meters. All right. So they gave me dx over dt. I want to know dy over dt. I don't have, nor do I need dz over dt. They haven't asked me anything about it. That's a good clue. So it's a right angle triangle, assuming that these builders are building the house properly and the wall is straight up and down. Those would be, the wall and the ground should be perpendicular to one another. Should be. So I know that x squared plus y squared equals z squared. And I know that the derivative of this would be, if I did the derivative of x, but I'm actually going to fill in, instead of z squared, I'm actually going to put the value in. I'm going to put 4 squared. There's a reason why I'm going to do that, because if I don't, when I do the derivative over here, if I leave it as z, I'm going to have a dz over dt. I don't have any information about dz over dt, and I don't want any information about dz over dt. They haven't asked me anything about it, so I don't want it in my question. So by making this an actual number instead of a variable, when I do the derivative, it will be 0, and I won't have a dz over dt. So If I do the derivative of this, so I could do x squared plus y squared is 16, because 4 squared is 16. If I do the derivative of this, I'm going to bring my 2 down, decrease the exponent by 1, but I have to say I did the derivative of x with respect to time. Plus, if I do the derivative of y, that is 2y, but I have to say I did the derivative of y with respect to time. Now if I do the derivative of 16, that's 0. And so there is no dc over dt. Well, there is, but it doesn't matter because 0 times dc over dt would still be 0. Anyway, so now I can fill in numbers. We're going to run into a problem though in just a second. You may already see it, but just in case you don't. So 2 times x was 2, times dx over dt, which was 0.25, plus 2 times y. Here's the problem, I don't have a y. Times dy over dt, and dy over dt is what I want to know. I want to know at what rate is the lumber going down this side. So I need to figure out a y, but I can do that because I know that's 2, I know that's 4, and I know that x squared plus y squared equals z squared. So I know 2 squared plus y squared is equal to 4 squared. So I know that 4 plus y squared equals 16. So if I move this over here, I have y squared is equal to 12. And so y is equal to the square root of 12. Now 12 is 4 times 3, so that's 2 root 3. I don't imagine that they put it as a decimal. Maybe they do, but I doubt it. If you did it as a decimal, it wouldn't be the end of the world. I'm going to leave it here as 2 root 3. I may end up changing that in the end. I'm not sure yet. So here I have 2 times 2, which is 4, times 0.25, which I believe should be 1, plus 2 times 2 root 3 would be 4 root 3. dy over dt equals 0. So 4 root 3 dy over dt would equal negative 1. So dy over dt would equal negative 1 divided by 4 root 3. Now, this was given as a decimal, so I would probably change that to a decimal. So 1 divided by 4 root, where's my root button? There it is. Root 3 is negative 0.14 meters per second. Makes sense that it's negative because it's sliding down. For those of you in physics, you know that usually we assign down to be the negative direction. So it makes sense that it's down. So again, in this one, because we did not know dz over dt and we were not asked to find dz over dt, I made this a constant when I did it. All right. The last one is number 9. And in number 9, oh yeah, these guys have weird names. All right. Kruno and Zarko, I don't know. Kruno and Zarko leave Coffee World at the same time and they head for their respective homes. Kruno rollerblades east at 20 meters per minute. So Kruno goes east at 20 meters per minute. So that would be a dx over dt. Again, I know it's time because that's time. And I know it's x because it's going across. And Zarko bicycles north at 26 meters per minute. And so that is a dy over dt. Now, At what rate is the distance between Kruno and Zarko increasing 2 minutes later? So the distance between them, well, if he's here and he's here, I'm assuming they're guys, the distance between them would be the hypotenuse, right? Now we have to do some logical reasoning here because they didn't give us an x, they didn't give us a y, and they didn't give us any information. So we want to know at what rate is the distance between them increasing. So this time we actually want to know dz over dt. So again, I know this is a right angle triangle, and I know we're going to have x squared plus y squared equals z squared. I'm not going to replace z squared with a number this time because I actually want dz over dt in my formula. So when I do the derivative of this, we have 2x times dx over dt, right? Just did the derivative of x squared, plus 2y dy over dt is equal to 2z dz over dt. Now if you want to, because there's a 2 in this piece, there's a 2 in this piece, there's a 2 in this piece, you can just divide the whole thing by 2, and you would have that. If you want to leave the 2 there, it's fine. If you want to take it out, it's fine. The problem is I don't have an x, I don't have a y, and I don't have a z, but I actually have the means to get it. Because in the question it says, at what rate is the distance between the two people increasing 2 minutes after they leave the coffee shop? So if this person is going 20 meters every minute, and we're looking at 2 minutes afterwards, that means that this guy must have gone 40 meters, because he goes 20 meters in the first minute and 20 meters in the second minute. This person is going 26 meters per minute, so in the 2 minutes after they leave, he has gone 52 meters. So I can figure out Z. I have a calculator. I can figure out Z because we know x squared plus y squared equals z squared. Hope this is in the frame. So 40 squared plus 52 squared equals z squared. And so I can figure out z. I'm just going to do 40 squared plus 52 squared. And then I'm going to take the square root of that. And I'm going to get 65.6. So z is 65.6. So now that I have all this, the only thing I don't know is dz over dt, which is what I want to know. So I'm going to go back over here. I divided everything by 2. So my x is going to be 40. dx over dt is going to be 20 plus y is 26. dy over dt, oh sorry, y is 52, my apologies. Y is 52, dy over dt is 26, is equal to z, which is 65.6 times dz over dt. Then you just solve for dz over dt. I'm assuming you can do that. I'm going to let you do that. Hopefully I've answered some questions. If you still have questions, please let me know. Again, your test is going to be on Monday, so you have some time to figure out if you have any questions that you want me to answer. I will probably start into chapter 6 tomorrow unless there's a bunch of questions I need to answer, all right? So we'll talk to you again tomorrow. Bye.